This, this is chapter 5.4, problem number 81. And it's a good problem because it has to do with graphing logarithms, finding inverses, then graphing exponential functions, because exponential functions and logarithms are inverse of one another. So the problem first says find the domain of f. So here's f of x. And I'm going to start out by changing this around a little bit because, sometimes they try and trick us. And this is really the same thing as f of x is equal to log base 3 x plus 2 plus 3. And I'm making this change right there because I want to be very clear that this is my h and this is my k. And just because I put it in the front here, it's still the constant, it's still outside of the function, and it just makes it a little bit easier to read if I put it in a format in which I am more comfortable. So don't let them trick you with that kind of stuff. The first question they're asking me is, what is the domain? And I look at my function here, and I want to see if there's anything that is going to be restricted. I'm going to look for, are there any denominators that have a variable? No, there aren't. Are there any radical signs that have a variable underneath it? No, there isn't. However, there is a logarithm, and the logarithm has an argument. The argument is x plus 2. And the argument of a logarithm has to be a positive number. The argument of a logarithm cannot be 0, and it cannot be negative. So what I'm going to do is I'm going to set x plus 2 has to be greater than 0, and then I'll just solve for it. Negative 2 on both sides, subtract 2. So x has to be greater than negative 2. So my domain of this function is, I'm sorry, I'm using a tablet and it's kind of clumsy. I'll try and get better as I go along. My domain of this function is negative 2 to infinity. And notice I have a parentheses, not a bracket, because negative 2 is not included. If x were equal to negative 2, then I would have 0 as an argument of my logarithm, and I can't have that. My next step is they're asking me to graph this function. So I'm going to start with the parent function, which is log base 3 of x. So that is y equals log base 3 of x. And it's much easier to graph a logarithmic function when you put it into its exponential equivalent. So I'm going to take my little base 3, I'm going to move it over to this side, I'm going to bump up the y into be an exponent, and I'm going to have 3 to the y is equal to x. It's much easier to graph it that way, even though it's a little bit backwards. So I'll make a little table of values, x and y. And I'm going to start with my y values. And the y values I want to use are the ones that I know are going to be in every logarithmic function. So I'm going to start with 1. When y is equal to 1, x is going to be equal to 3. When y is 0, x is going to be equal to 1. And when y is negative 1, x is going to be equal to 1/3. You need to know these. On an exponential functions, not a logarithm, the exponential, we always have the points 0, 1, comma, 1a, and negative 1, comma, 1 over a. On a logarithmic function, we always have the inverse of those, not surprisingly. So we always have the points 1, 0, a, 1, and 1 over a, negative 1. Always, always, always. And you can see it right here. So I have the point 3, 1. That fits this, that matches this right here. So I'm going to go to the point 3, 1. I'll put that in right there. I have the point 1, 0 right there. And I have the point 1/3, negative 1 right there. And I know that my logarithmic function, I'm sorry this is going to come out poorly, but I'll try my best. My logarithmic function has an asymptote on my parent of the y-axis. It cuts through those 2 points, and then it kind of flattens out. So that is the parent function right here. Now, I need to transform it. And fortunately, there's no a and there's no negative sign. So all I need to do with this is I need to move it left by 2 and up by 3. So I'll take my, first of all, first thing I'm going to do is I'm going to move my asymptote. So I'm going to make myself an asymptote right at -2. I'm moving my everything over by 2. I'm going to move my asymptote over by 2 also. So I'm going to draw my line right here, nice line. I think I'll make it a dashed line. I better make it a dashed line. Works better that way. Line style. Nice dashed line. There we go. So there's my asymptote. Now I'm going to just move my points. So let me get a different color. Let's use blue. So I'm going to move this point here, which was 1/3 -1. I'll move it over here by over left 2 and up 3. 1, 2, 3. So that point is right about there. I'm going to move this point here, which was 1, 0, left 2, up 3, right there. And I'm going to move this point here, which was 3, 1, left 2, up 3. So my 3 points now, this is now 1, 4. This point over here is -1, -3. And this point over here, this is a weird point. It's hard for me to do here. But that would be -1 2/3, 2. So all my points have just shifted over, and now since I have a nice asymptote, I can kind of make my logarithmic graph. I don't want to cut across that asymptote, I'm sorry. And it looks like that. So that is my transformed graph of this function. Part C is telling me to, from the graph, determine the range and any asymptotes of f. Well, from this problem right here, we determined the domain. So from this graph here, can we determine the range? Yes. It's a logarithmic function, and the range is r -infinity, because it's going down as low as it'll go, and it's going to go all the way to +infinity. Does it have an asymptote? Yes. We already determined that this right here is a vertical asymptote at x equals -2. Notice how that coordinates with my domain. I can't go any farther negative than -2. I have a vertical asymptote there. The next thing I need to do is I need to find the inverse of this function. So I'm just going to take every step that I need to do. And the first step is change my f of x into a y. So y equals log base 3 x plus 2 plus 3. And the second thing I'm going to do, which I always do when I'm finding an inverse, is I'm going to switch my x's and y's. So x is equal to log base 3 y plus 2 plus 3, and now I have to solve for y. Well, my y is trapped in this logarithmic, as a part of a logarithmic argument, and I'm going to have to free it. But before I can free it, I need to get rid of all the debris that's around this logarithmic expression, which is this +3. So I'm going to subtract 3 from both sides of my equation. And I'm going to have x minus 3 is equal to log base 3 y plus 2. Well, now I can free my y by turning my logarithmic expression, my logarithmic equation. Well, really what I'm doing here is I'm exponentiating both sides to the power of 3. But when I have a log and I want to turn it into its exponential equivalent, I'm going to do this. I'm going to take my 3 and I'm going to move it over to the other side like I did before. And I'm going to make my x plus 3 the exponent. Because remember, a logarithm is a question and the answer is an exponent. In this case, the logarithm is a base 3. It's saying what exponent, x minus 3, has to go on top of the base 3 in order to have an answer of y plus 2. So this is going to look like 3 to the x minus 3 is equal to y plus 2. Well, now I've almost succeeded in isolating my y. I can just subtract 2 from both sides, and I have 3 to the x minus 3 is equal to y. Don't stop there. Don't forget that that is not the end of this equation. That's not the end of this work. What you need to have next is you need to say f minus 1 of x, the inverse, is equal to 3 to the x minus 3. Hang on a second, let me make this look a little bit better. Is equal to 3 to the x minus 3 minus 2. That is the inverse of this function. Now, looking at this function, let's see, what is my domain of this inverse? Well, do I have anything in any variables in a denominator? No. Do I have any variables underneath a radical sign? No. Do I have any variables that are part of the argument of a logarithm? No. So the domain of this function here is negative infinity to infinity. And if I go back to my original function, that confirms the range of my original function. My domain of the new function, of my inverse, those are the x values of my inverse, and that would make those the y values of my original function. Now, the range of my original function, the domain of my original function was negative 2 to infinity. So that should be the range of my inverse. Well, I think what we need to do is we need to graph the inverse here and see if that is in fact the case. Let's graph the inverse, again, starting with the parent function. So my parent function here would be 3 to the x. Notice it's an exponential function. So let's get a pen here. It would be 3 to the x. So y equals 3 to the x. Exponential function. 0, 1, 1a, which is 3, negative 1, 1 over a, 1/3. So my exponential function looks like this. Negative 1, 1/3. 0, 1, 1, 3. You know, my exponential functions have horizontal asymptotes of the x-axis. There is the graph of my exponential function. It's kind of curvy, but at the top, you get the picture. So now I need to transform it. How am I going to transform it? I'm going to go to the right 3 and down 2. So before I do anything, if I'm going down 2, I think I better move my asymptote. So take a nice asymptote here. It was the x-axis. Now my asymptote is going to be at negative 2. There it is. Let's make it a nice dashed asymptote. Oh, sorry. There we go. And I'll move my points. I'll move my points right 3 and down 2. So one different color here. Okay. So to the right 3, it was -1. 1, 2, 3. Down 2 was very close to the asymptote, right about there. 1, 2, 3. Down 2. 1, 2, 3. Down 2. This point here is 4, 1. This point here is 3, -1. Sorry. And this point here is, looks like 2, negative be 1 2/3. And my graph, my exponential graph, is going to look just about like that. Notice, I have the point 4, 1, and the point 3, -1, and the point 2, -1 2/3. I'm going to go take a look at my other graph here of my original function. The point 1, 4, x and y switched. The point -1, 3, x and y switched. The point -1 2/3, 2, x and y switched. So we do have an inverse function here. And we notice that our domain on this function, our original function, was -2 to infinity. And if we look at our graph here of our inverse function drawn, our domain is also, our range is -2 to infinity. So that pretty much answers all the questions for this problem. Good problem, a good way to understand inverse and the domain and range of logarithmic and exponential functions.